In this video, I will try to show you how to solve absolute value equations. Absolute value tends to show up in some of the more difficult problems in Algebra 2. And the reason for that is because absolute value is not, does not behave consistently. It has two different behaviors. So we see here the definition for absolute value, and this is written very mathematically, but all it's really saying is that if you put a number into absolute value, you'll just get that number out if the number is positive. And if the number is negative, you'll get the opposite of the number. So as these two behaviors, we often like to say it just makes the number positive. And that makes it seem like absolute value has one behavior, but it's very important when you are solving absolute value equations that you think of it as having these two behaviors. One is it does nothing, the other is makes it its opposite. So that's the right way in terms of solving equations, I think, or the best way to think about absolute value. And here's some examples. The absolute value of 3 is 3. The absolute value of negative 2.5 is positive 2.5. So now we're ready to look at solving an equation here. So here's the equation I've written. I've written the absolute value of 3x minus 2 is equal to 7. And so I'd like to solve this. The problem being, though, I don't know which behavior absolute value is going to do to this expression on the inside, because I don't know whether 3x minus 2 is positive or negative. In some cases, say if x is a half, so x is positive, the result inside of here will still be negative. And in other cases, if x is, say, 5, then the result in here will be positive and it will do nothing. So I just need to break it up into two cases. And this will be our big approach all the time, is to break it up into two cases. One case is where 3x minus 2 is negative. So if 3x minus 2 is negative, then absolute value makes 3x minus 2 into its opposite. So I put an opposite sign here in the front. I put parentheses, so I'm taking the opposite of that whole expression. And then I just solve that algebraic linear equation the way I know it is, and I get this answer here. The other possibility is that 3x minus 2 is positive. And again, so now that means the absolute value does nothing, so I just take them off and I don't need to worry about anything. And I solve it, and I get a solution. Do these work? Well, let's just plug them in. If x is 3, then I get 9 minus 2 is 7. 7 is a positive number, so that's the case where 3x minus 2 is positive. Over here, I'm going to plug in negative 5/3 for x. 3 times negative 5/3 is negative 5 minus 2 gives me negative 7. The absolute value of negative 7 is 7, so that one works too. So, and it was when 3x minus 2 was negative. Since we didn't know whether the number on the inside was positive or negative, it's possible for us to get something called extraneous solutions. So it will be important for you to test your solutions. So please don't forget that. And I hope you see here another important thing to remember is to split the absolute value into two cases. That seems like just more work for you, but it's the essential way to solving these problems. Split it into two cases. In this part here, I've shown a much more complicated equation. Okay, and the reason it's complicated is it has an absolute value here and another absolute value here. So what are we going to do? Well, we're going to make two cases for what can happen here, and we're going to make two cases for what can happen here, and that's going to turn into four giant cases. One where they're both positive, one where the first is negative and the second's positive, one where the first is positive and the second's negative, and one where they're both negative. And each one of these is going to turn into a different equation, and it's going to have a different solution. And we would need to solve all four of these solutions out, but they're all fairly simple. So what do I need to do at this point? Solve and check. In fact, let's just try and work a few of these. Some of them are not so easy. So let's take the first one here. When I simplify this out, on this side I get -1 is equal to 5. What does that mean? Well, that means that there's no solutions to this part. So that's kind of easy. There's no way for when both of these give positive values for us to get 5 here. And over here, on this last one again, we get 1 is equal to 5. So again, not possible for there to be solutions. And then let's look here where it's sort of easy because we're adding. We get 2x plus 3 is equal to 5. That means that 2x is equal to 2. That means that x is equal to 1. So does that work? So if I put 1 in here, I get 2. And that agrees with the absolute value being positive. If I put 1 in here, I get 3. Well, that's not going to be where the absolute value does something, where the number on the inside is a negative. So that turns out to not work, even though that's exactly the number we got from here. And so this is why it's so important to check. So let's just wrap it up here. What's the important things that we learned here? Well, first is that there's always two cases when we've got absolute value, at least. One when the inside is positive, and one when the inside is negative. And the second thing is to check solutions. Thanks a lot. I hope this helps.